Looks like we're good to go. Each time I do this, it gets a little less awkward in the beginning. All right, well, thank you for coming. I know this one wasn't planned in advance. I kind of decided to do this one just this morning. A bit of a spur of the moment decision. And the topic will once again be the sort of ongoing episode of very wet and stormy conditions in California that have had a growing number of impacts throughout the state. The next wave is sort of moving through right now, kind of a moderately strong storm in Northern California. Probably the most substantial wave to go will come in this weekend. The first phase on Saturday and the second phase late Sunday into Monday. And then it looks like this pattern is actually going to taper off. Most of California is going to get a substantial break, about 6 or 7 days out, lasting indefinitely. So it does look like this very wet pattern with all the flood and wind damage related impacts we've been seeing does have a relative expiration date. Significant conditions to get through between now and then, though. Today's precipitation already again resulting in at least minor flooding in Northern California, with some ongoing river flooding, particularly along the Salinas River and the Merced Rivers right now. That's sort of where the ongoing flood impacts are most significant. The flooding of the Salinas River has inundated large swaths of agricultural land in Monterey County, and actually has the potential to temporarily cut off parts of the peninsula from the Monterey Peninsula from the outside world via road, at least for a couple of days. This has happened before. It's because each of the major roadways departing have very flood vulnerable low-lying spots, and it's possible that all of those will become inundated at some point in the next 24 hours. So that's some significant flood impacts along the Salinas River. There actually have been some private levee breaks along the Salinas River, which have deeply inundated mainly agricultural land. There are some farmhouses that have also been flooded, but in general, these are not significantly populated urban areas that are affected by these levee breaches. So, generally it's not what you want to see, but it's also different than some of the major flood protection levees having a problem. This is not that. Merced River, the Bear Creek in Merced, I think, is the body of water that's done most of the significant flooding there. Low-lying areas around Merced have been now flooded for several days, and that does include places where people live. Most of the city of Merced itself is okay, but the lowest lying parts of it have experienced some significant and fairly prolonged inundation. So the last wave of the storm really was focused on Central California rather than Northern California. We're talking about the one a few days back, and it did produce widespread flooding, including some significant flash flooding and debris flows all the way from about southern Monterey County south into Ventura and Los Angeles counties, where everyone really from about the city of LA proper up through Big Sur saw some pretty dramatic rainfall earlier this week from an atmospheric river that not only was slow moving, which sometimes happens as it intersects the transverse ranges, where the topography of California's coast shifts from being sort of northwest southeast oriented in the northern 2/3 of the state to sort of having a short segment of essentially east-west coast right around Santa Barbara, right around where the transverse ranges are very close to the ocean, and really effectively intercept water vapor moving quickly from south to north, because that's almost directly perpendicular to the mountain range there. In that segment of coast, it wasn't just the fact we had a really moist atmospheric river plume, but it was also the fact that it was convectively unstable. So the atmosphere was favorable for spontaneous vertical development of deep clouds and thunderstorms. And so in something that is a fairly unusual sequence of events, a lot of the heavy precipitation was in fact associated with thunderstorms, thunder and lightning, along with significant winds in Southern California. And so the flash flooding, the debris flows we saw in Ventura, Santa Barbara, San Luis Obispo counties, areas in there, which was quite significant, with a lot of roads that are still either closed or partially closed, with some damage. That's a bit of an unusual thing to see so much lightning and thunderstorm activity associated with these storms. And so those impacts along the central coast and parts of Southern California, about as far south as LA County, have been significant, although they have tapered off because the rain has not been as persistent there as in the north. It's mainly been that one huge storm earlier this week that caused most of the problems south of about Monterey County. South of Monterey County, I think that the inbound storms will have a somewhat lesser impact, but they will affect the entire state going into this weekend. One other thing to note is that this is not, the storm earlier this week was not the only one that's brought an unusual amount of thunderstorm activity. We've seen that almost all of the storms in this sequence, particularly in the latter half over the past 10 days or so, have been very convectively active. We've seen huge amounts of lightning over the ocean associated with these, which again is not typical, especially because a lot of that lightning has maintained itself, and we've seen strong and even severe thunderstorms make landfall essentially across California during some of these events. And they haven't just been associated with the cold fronts, but there have been these strong convective bands, organized convective thunderstorm features, sort of quasi-linear features in the atmosphere that have produced significant severe weather-related impacts. In fact, there has been at least one confirmed tornado, an EF1 tornado, I think it was in Merced County, that lifted a barn off of the ground and threw it somewhere else, among other things. But the more widespread effects have actually been in the southern Sacramento Valley, including the city of Sacramento and Davis, as well as in the Santa Cruz Mountains and parts of the North Coast, where some of these severe thunderstorm bands, most of which have moved through in the middle of the night, have produced really severe gusty winds that actually have been some of the strongest winds during this entire event. The remarkable thing about some of these storms is they appear to have caused damage that significantly exceeds the wind damage we typically see during winter storms, and it's not impossible that some of these were due to localized tornadic spin-ups. Small, relatively weak tornadoes can still produce quite a lot of damage, partly because the winds are different than straight-line winds. They are, of course, more swirling and rapidly changing winds, which can cause different kinds of damage than just linear gusts from the same direction repeatedly, as we typically see during winter storms. So there are some confirmed waterspouts that occurred off the coast. There's some photographs. There's radar imagery that supports it. There is at least one confirmed tornado of relatively significant strength. EF1 in Northern California is notable, especially because it occurred at night and wasn't associated with pop-up thunderstorms, but actually as with the linear convective features. So there's been lots of wind damage in the Santa Cruz Mountains, lots of wind damage in the southern Sacramento Valley, and a lot of it has been associated with severe thunderstorms, which again is not typical for winter storms in California. And in some ways, that has been the greatest impact from the storm sequence, is this really intense and widespread wind damage in some areas, not everywhere, but particularly in the southern Sacramento Valley, certain parts of the central Sierra foothills, and in the Santa Cruz Mountains. This wind damage has been hugely disruptive, and a lot of folks who live in the relatively rural parts of these regions are still without power and often without road access. So this has been going on for days now, and so this is a significant issue. I suspect a lot of those folks probably aren't able to join us today unless they have a Starlink set up with a battery backup or something. So those stories are probably going to continue to trickle out in the coming days. Why have these storms been so convectively unstable is a question I've been getting, and the answer really is that this does tend to happen with this kind of pattern. It's just that we don't get this pattern very often. It's more commonly a strong El Nino pattern where we have this really enhanced jet stream, this polar jet stream really far south over the eastern Pacific Ocean right at California's latitude. So two things happen there. We get an unusually strong mixing of warm, moist, sort of subtropical air masses in the form of these Pineapple Express type atmospheric rivers on the one hand, and then we also get this pretty cold air aloft from the Gulf of Alaska mixing. So it's that these warm and cool air masses sort of converging in a way that they don't tend to do as often in California as they might somewhere else. That's producing some of the instability for both the cyclonic storms themselves and then these individual sort of convective features, these thunderstorms as well. And it's also because we have not just the atmospheric instability, which is one important ingredient, but we also have this what are known, favorable jet dynamics. In other words, we have the jet stream in a position and configuration that favors upward motion in the atmosphere. So not only is there enough instability for these storms to bubble up, but there is enough vertical motion coming from the jet stream and also enough horizontal and vertical wind shear to essentially generate storms that start to spin, which is a characteristic of thunderstorms that become strong to severe, that has supported these successive waves of strong to severe thunderstorms producing torrential downpours, severe wind gusts, and even a couple of tornadoes. These have been pretty well forecast, I would mention, by the National Weather Service and the Storms Prediction Center, but it's often hard to know exactly which areas are going to be most severely affected by these, and so I think it's been a little bit underemphasized, and so it's taken some folks by surprise, even though these actually have been repeatedly in the forecast the same days when these highest impact events have occurred. More of this is potentially on the way this weekend. As I mentioned, a moderately strong storm is currently moving across especially Northern California. As we speak, more moderate to locally heavy rain. Not a tremendously intense storm, but again, it's yet another rain event in the sequence. The storm due in tomorrow is going to be stronger than the present one. I would call it moderate to strong in an absolute sense. And then another moderate to strong storm is expected late Sunday into Monday. Both of these storms will be colder storms, so we won't see the warm rains in the mountains as much as we have. That'll help decrease runoff a bit in the higher elevations, but it will also result in enormous snow accumulations on top of what has already been an extremely impressive snowfall season. This is going to be increasingly problematic with snow removal and road and travel conditions up in the mountains. This is really going to start to cause some disruptions up there as they get multiple feet of additional snow on top of what is already one of the largest snowpacks on record for early January. We're essentially getting close to peak seasonal values, and we potentially still have a couple or a few months of snow accumulation to go. So we'll see how high we get. I want to return to that in a moment. Because that extremely large snowpack has some both positive and potentially negative implications down the road. So we can discuss that a little bit later. The storm on Saturday is likely to bring more heavy rain, more strong winds, and yet again a chance of strong, maybe even locally severe thunderstorms. So we could see similar impacts to the storms we've seen recently statewide. Again, I think this will be concentrated in the northern half of California, but both of these storms are also going to affect Southern California as well. So I expect more flooding, the potential for more at least localized wind damage. Right now, I don't see that the potential for extreme winds is as high as with some historical storms, but again, we've already seen so much damage from the winds, and we've seen that the progressive impacts have gotten worse as soils are saturated. It's even easier for trees to fall over now because everything is just sopping wet. So again, there could be more power outages and more wind damage, even though I don't foresee an extreme wind event. I also don't foresee an extreme precipitation event this weekend, despite widespread moderate to heavy precipitation. But the impacts are going to escalate once again because everything is already completely saturated and there is some ongoing flooding. So there will be additional flooding this weekend, especially on smaller, flashier watersheds, so creeks and streams, urban areas, maybe the smaller rivers. It still looks like the main stem rivers, the major Northern California and Southern California rivers, probably won't see significant flooding. So we're talking about the Sacramento, the San Joaquin, and some of the other larger ones, simply because this isn't the kind of extreme rainfall that often results in that. And we also still have flood control headroom in some of the major reservoirs, Shasta and Oroville in particular. So this will be manageable on the large main stem rivers. I think we sort of are threading the needle and avoiding some of the worst case flood impacts that we might have seen had there been a more extreme individual storm upcoming in the sequence, or if the sequence were just going to continue indefinitely. But that's the other piece I wanted to touch on. Starting later next week, it looks like the rain is finally going to taper off in California, and a dry pattern, or at least a mostly dry pattern, is likely to emerge in about 7 or 8 days and continue for at least a week or so. That really is going to be helpful at this point because we've gotten so much water and so much snow that's going to help us dry out, dig out, heading into late January. It's really good news because it takes us off a trajectory towards continued worsening flooding. So I do think we're going to avoid some of the worst case flood outcomes. That's not to minimize what's already happened. This has been a deadly storm sequence. I think there have been about 20 deaths so far. The damages will probably be at least in the hundreds of millions, if not higher, before all is said and done. And again, the disruption to people, even people who have stayed relatively safe, there are a lot of folks who've been without power and without road access to where they live for a long time, and that is likely to continue for at least another 5 to 7 days before it starts to improve later next week. So for historical context, I just wanted to offer, since I've been getting this question a lot, how does this ongoing storm sequence compare to other things we've seen in the 20th century, and also to the Arc Storm 2.0 scenarios that we put forth in the work that we published this past summer? And the answer is, I don't have an exact quantitative answer yet, but some of the informal initial statistics put out by NOAA suggest that the first 16 days of this storm sequence, which is sort of where we were as of yesterday, has resulted in a statewide average cumulative precipitation of about 8.4 inches. Now, of course, some places in the mountains have seen over 30 inches. Some places in the deserts have barely seen anything at all. So it's an imperfect statistic that doesn't describe regional impacts. But in terms of aggregate statewide impacts, this is analogous to a metric that we do have for ArcStorm. And it suggests that we are on a trajectory that is notable in a historical context, but far from unprecedented. There are at least 3 or 4, maybe even 5 historical storm sequences that saw 16 or 17-day statewide precipitation accumulations at least as large as we've seen with this one, if not larger. And where we are at day 16, 17 of this event is significantly below either of the 2 arc storm scenarios that we set forth in our work this summer. It's below both the more less extreme arc historical scenario and well below the much more extreme arc future scenario, which describes what is plausible in a future warming climate in California. So as substantial as the impacts have been, this is not the arc storm. This is not a widespread catastrophic storm sequence in California. And again, although there have been major regional impacts and people have died in the storm sequence, I still think it's important to distinguish between what we're currently seeing, which is historically notable but not historically unprecedented, and the kinds of truly catastrophic and historically unprecedented events that we know are possible in California, even absent climate change. We've seen them happen before, for example, in the 19th century. Think back to the Great Flood of 1862, but that we know are also increasing. The likelihood of this is also increasing in a warming climate. And we found, again, this past summer in our work, that climate change has essentially doubled already the risk of an unprecedented historical mega flood event, which again is not what we're seeing right now. But there are parallels, there are shades of that in what we're seeing today, in the sense that it is a prolonged multi-week storm sequence with some weaker storms and some stronger storms. The difference is the present sequence is both shorter in duration, lower in intensity, and the storms themselves haven't been as warm as the kinds of storms that would produce the greatest flood impacts in California. So it's essentially less extreme in almost every foreseeable dimension than are the kinds of arc storm scenarios that we have sort of outlined in our work. One more thing I wanted to add about the climate change context of all of this. This is probably a topic for a day where I have a little bit more time, but in general we do expect to see increasing hydroclimate whiplash in a warming California, and there are indications that we're already actually seeing that in observations. That wasn't necessarily true 5 or 10 years ago, but we now have enough data and enough recent experience with extremes that this signal is starting to poke up above the noise, if you will. And that does mean, yes, more severe droughts on the one hand, but also more severe periods of extreme precipitation on the other, like what we're seeing now. And a best estimate right now, a conservative estimate as to how much more precipitation we're receiving during events like this, due to the warming we've already experienced, is about 5% more precipitation. But there's other work out there, and there's theory to suggest that the actual increase to date, or the attributable component of the climate change effect on extreme precipitation in California, is more like a 10 to 15% increase at present. So I think I'm pretty comfortable saying that the degree to which climate change has made this storm sequence or storm sequences like it wetter in California is anywhere from about 5% on the low end to 15% more intense on the high end. And that may not sound like a lot, but that can result in large increases in the relative amount of runoff we see during these events, especially if you consider that we're currently on track to more than double the amount of warming we've seen already. So what is today at more like a somewhere between a 5 and 15% increase, you double that and you get somewhere between more like a 10 and 30% increase. And here we're talking about much more runoff, and that's not even considering the effect of warming temperatures and warmer storms on runoff. So that's probably enough of the monologue. This is going to be a relatively short session, so I'm going to reserve 10 or 15 minutes for answering questions now. I see them coming in at a somewhat manageable pace, so I might be able to get through most of them today. Let's see here. I got a question from Rachel Ramirez about whether precipitation would flatline, whether the landscape will dry out for a bit after this set of storms. Do I think it'll be as dry as it was for as long as it was last season? The short answer is, well, especially to the latter part, no. I don't think it'll be as dry, severely dry for as long as it was last season, because that was essentially the historically unprecedented dry period between January and May for almost all of California in 2022. It was historically dry. That's a high bar. I don't think we're going to see that. Already we've seen enough precipitation in January that we won't be able to match those January through March or January through May statistics from last year. But I do think that much drier conditions, at least for a period of time, is good news in late January, early February, because we're currently in a flood situation. So we do actually want at least a temporary dry period after this to let everything settle down. The nice thing about how much water we've gotten is the landscape isn't going to quickly dry out. Everything is completely saturated. There's a huge snowpack in the mountains, and so that's not going to go away quickly, even if we do have an extended dry period. The dry period coming up also doesn't necessarily look particularly warm. It actually could be cool and dry, especially in Northern California, so that will help sort of hold on to the moisture in the snowpack for a while. As for the rest of the season, we're still sort of in a decaying La Nina pattern, so from a seasonal predictive perspective, it's still more likely than not that the rest of the season will be somewhat drier than average, but of course the context of that is now that we've had this exceptional wet period leading up to it. So unless it goes completely dry again, like it did last year, and I think that's unlikely, the consequences aren't going to be anywhere near what they were last year in terms of this incredible sequencing. Now, could we see an extended dry period and drier than average conditions for the rest of the season? That is entirely possible, and that would actually be quite striking if we did. But again, we currently have what is arguably a massive snowpack for the time of year, and everything is completely saturated. So even if that happens, the consequences would be different than they were last year. So we'll see where we're headed. It does look like things are going to dry out in about a week and stay drier for at least a week to 10 days. Maybe a minor precipitation event or two, but nothing that would further exacerbate flooding, and it probably will be dry most of the time in most places during that window. We'll see what happens the rest of the winter. I can check back in about that in a week or two with everyone. I think that actually answers the next question from Charles as well. I did briefly touch on the potential damages. It's difficult to speculate. Often it's hard to know until all is said and done, particularly because some of the worst damages in the hardest hit areas has not fully been known yet, and especially in areas that were hardest hit by wind damage and mudslides in the mountains. A lot of folks are still dealing with that in real time, and there could be additional problems this weekend. So even though I don't foresee widespread major river flooding this weekend, there will definitely be more flooding of urban areas, creeks and streams, and maybe some smaller rivers. So and more mudslides. And the issue with mudslides is probably going to peak this weekend, because that's really a question of cumulative soil saturation, and we're absolutely at that point now. So there, whatever the damages are today, there will probably be some more this weekend, and so maybe we'll have a better sense next week of how things actually shook out. Let's see here. I addressed the context of ArcStorm, and we can talk more about that later. But again, this is just a brief conversation today. So I thought I've probably said everything I'm going to say about ArcStorm for now. Will the state be creating, well, I will answer this one, be creating new flood maps based on ArcStorm 2.0? The answer is yes. We're working with the California Department of Water Resources to do this in conjunction with Oak Ridge National Labs. It looks like this is going to happen this year in 2023. And I'm currently, one of the reasons why I'm doing a short session today and not writing another blog post or something is because we're frantically submitting a proposal to the new the University of California Climate Initiative, so that we can find some tangible support to bring together folks at a bunch of different UC campuses and California state agencies to finish this project and really bring ArcStorm 2.0 full circle. So we're actually trying to get this third and final phase funded. So the second phase is, again, this flood modeling, which is now going to be underway shortly, supported by the California Department of Water Resources. And we're trying to work on the getting support for the third phase, which essentially is going to be really assessing the social and economic impacts of these sorts of events and then how to mitigate them. So, okay, so how bad would this be in real practical terms, and then what do we do about it to make these kinds of scenarios less bad? Again, remembering that we're talking about storm sequences that are significantly worse than what we're currently experiencing. So the impacts of these would clearly be more severe and more widespread than the substantial effects that we're seeing right now. One question is whether this precipitation will significantly replenish the deep confined aquifers in this case the northern Sacramento Valley, but I'll broaden it to the Central Valley more generally, that has been depleted over the past couple of decades. The answer to that, and I'm not a geologist or a hydrologist, so I'll defer to those who are, but having worked with both of these types of folks on current projects, it takes a lot more than a couple really wet weeks to replenish deep aquifers. The unfortunate reality is that even really wet periods like this can only do so much, and there's two reasons for that. One is that when precipitation falls heavily, a lot of it does become runoff, and it flows into rivers and causes flooding and eventually makes it out into the ocean. So a lot of that water isn't necessarily just sitting on the ground for weeks, as it might have prior to sort of anthropogenic human interventions in the valley. So, we built up, we have agriculture, we have levees, and we have structures to move water more quickly through these river systems than they would naturally have gone. I mean, prior to the construction of levees and dams and other flood control structures, these rivers would have flooded more frequently and with, greater geographic breadth. So the natural floodplains are much larger than the floodplains that we've constrained these rivers to today. And that would have resulted in more recharge of groundwater. And we also wouldn't have had all these straws in the ground, if you will, of these wells pumping the groundwater out. So it's a supply and demand problem. We're taking water out of these deep aquifers much faster than we're putting it back in at this point. And it's hard to put it back in. The geology doesn't allow for water to just percolate all the way down to the aquifer everywhere. There are really only certain places where the geology is actually favorable for that. So even when you see these areas that are flooded, it may or may not be an area that is favorable for all that water percolating downward into groundwater. So in other words, it helps. I mean, it doesn't hurt, certainly, but there's a real question of whether or not we have enough water sitting in areas where it can actually, for long enough, where it can actually percolate down to the deep aquifers. And the answer is, in the grand scheme of things, this is, we would need a bunch of really wet years, and we would also need, we would need more sustainability of groundwater management in the first place. We need to find better ways of recharging it by spreading the water out for longer periods of time in the right places. And we would need to be taking less out, in the meantime to balance that. So that's part of what the Sustainable Groundwater Management Act is intended to achieve in the long run. But in the short run, it's potentially having very different effects. So we can talk about that more at some other point. But in general, obviously events like this help more than they hurt, but there's a question of how much do they actually help. And they help much less with groundwater recharge than they do with surface water recharge. So our reservoirs are going to look in pretty good shape, I think, after the storm sequence, which is good. That helps us in the short to medium term. But in the long term, groundwater is still going to remain a big problem. All right, here. A few more questions. I think I'm going to keep reading down here. I'll give folks an extra 5 or 10 minutes, but I will have to probably sign off in about 5 or 10. A question from Jack Lee, related to the question from Merlin about a snowpack. Jack Lee asks, I mentioned that possible downsides of so much snowpack. Could you talk about that a bit? Yes, obviously it's good news from a water supply perspective, and it's a good news from an ecological perspective, because now we're going to have a lot of water that's going to more slowly melt in the coming months, and hopefully this retain some of this into the spring and summer months. We are seeing snowpacks melt earlier and earlier in a warming climate, but this is a big enough one that perhaps it will linger longer into the summer than recent snowpacks have, since it's just absolutely quite large. The challenge is that since we've essentially reached 100% of the average peak seasonal snow accumulation already in some places, with months left to go in the snow accumulation season, that does open the door to the possibility that if we were to get particularly unlucky and see a very warm storm sequence later this winter, in particular in, say, March, which is probably the most likely time for that to happen, or perhaps early April, we could have a significant snowmelt and rain-on-snow type flood risk, conditionally on there being an event that actually results in rapid runoff and snowmelt. So right now, obviously, there's no indication of that happening in the short term or medium term at all, and there's a good chance it won't happen at all this year, but it is the kind of thing that risk managers and flood managers in California are going to be considering when we think about how much headroom we're going to need to keep in reservoirs, when we think about how we're going to manage downstream water over the next few weeks as these storms eventually recede. There is this huge volume of water now stored up in the mountains that has the potential to melt more quickly than it used to, because the climate is warmer than it used to. So we might get a nice gradual decrease in that SWE, that snow water equivalent content, through the spring and summer, which would be ideal for drought alleviation and for ecology of the region. Or we could lose it quickly if we get a warm storm or a big heat wave potentially in the late winter, early spring months. So that's something we're going to be keeping an eye out for. But right now there's no indication of that. But that's sort of what I mean about just the potential costs and benefits of having a really big snowpack this early in the season. The good news is it's a lot of water that we need stored up there, potentially going to melt at a convenient time for us. The downside is it could also potentially melt at a very inconvenient time for us, and that's sort of what I'm talking about there. All right. Looks like that's about it. Again, this was a short one. The rest of my office hours are usually a full hour or longer in length. This one, just out of necessity due to deadlines, I'm keeping short. But thanks for listening, and as usual, this will be recorded and up, and I think the high-resolution version of it takes an hour or two to become available, but you can rewatch the fuzzy version of it immediately, I think. So thanks again for listening, and I will see you all next time. Stay safe and dry out there.